All right, so then yesterday we left off on the back side. We had just done straight chains and we had done the branched ones. But I think on the AP exam, if they give you anything, they're going to give you something with a functional group. In particular, what they like to give students a lot are alcohols, aldehydes, and carboxylic acids. I don't think I've ever seen too many ketones or ethers or esters. And so that's why I didn't bother giving you the suffix for those. Because really primarily that's what they focus on. So you have to know that anytime that you have an OH attached to your chain of carbons, the kind of compound that you have is an alcohol. All right, so anytime you see OH anywhere on a structure, it's an alcohol. So like, for instance, glucose. Glucose has OHs everywhere. Glucose is technically considered an alcohol. All right? I know, right? You're all alcoholics if you eat a candy bar. All right, now, the others, they give a lot. They give aldehydes a lot. Aldehydes are chains of carbon that terminate with this kind of a structure, where that last carbon in the chain, it could be the first or the last, it doesn't matter. It just has to be one of the ends. Has a double bonded oxygen on it and then a hydrogen on the other side. And you'll notice that these pictures are not the best because they're only putting in the atoms, they're not putting in any unpaired electrons, but you should be aware that this is kind of on the lazy side. When you draw a dot structure on the AP exam, you have to make sure that you also include those unpaired electrons, even though they're missing here from these pictures. So an aldehyde has this structure on the end. So remember that FRQ question? Methanol versus methanal? There's a difference in structure. Methanol would have one carbon and this attached to that carbon. Methanal would have that attached to the carbon. Completely different chemistries. Okay? Sometimes you'll have ketones. Ketones are chains of carbon where somewhere in the middle, one of those carbons has a doubly bonded oxygen onto it. All right? And then carboxylic acids have this structure on one of the ends. So it could either be the first carbon or the last carbon, not in the middle, right? So this is first or last. This also is first or last carbon. And these here, middle carbons. That's where you see those. So either in the first or the last carbon, you're going to have that carbon with a doubly bonded oxygen on one side and then a hydroxyl on the other. We call that OH group a hydroxyl group. When you write their formulas in non-structural ways, you'll see that the formulas are written with like this, CH3COOH. Anytime you see this COOH, you should know that that's the structure it takes. All right, so now, 2 FRQs in a row, I've given you a carboxylic acid. So this structure is really important. I need you to memorize the structure. All right, otherwise I wouldn't keep giving it to you. Alcohols, when you write their formulas, so like for instance methanol, you'll write CH3OH. You can stick them anywhere. Anywhere. So if you want, we can write that. Anywhere. And there's other functional groups beyond this, right? There's esters. Esters have some carbon in the middle has a doubly bonded oxygen, and then there's another oxygen between carbons in the parent chain. Or then there's amines where you have NH2 attached, and this could be on anywhere on that carbon chain. But these are not ones that they focus on, that the College Board focuses on. But when you get to organic chemistry, you better, bet the farm that you'll have to know them. Okay? All right, so let's take a look at how to name them. The naming of these things is basically the same as what we've done before. Here's an example. Here we have 3-methyl-3-hexanol. So let's break down the name, and then let's do the other ones. So first thing you need to do is figure out what the longest chain of carbons is. So everybody, guys, look up. Okay, so what's the longest chain of carbons? Is it 1, 2, 3, 4? These guys in here? No. You want to figure out the longest number of continuous carbons, even if you have to wrap around, right? So, is it 1, 2, 3, 4, 5, 6? Is that the longest number of carbons that are continuous, attached to each other? All right. So that's the longest chain. So I'm going to highlight it. That's my parent. 1, 2, 3, 4, 5, 6. All right, so what's the prefix for 6? Hex. What kinds of bonds do you see between those carbons? Single, double, or triple? Single. So that's why after hex you put the an, the root an, an. If there had been a double bond in there, you would put en. If there had been a triple bond in there, you put yn. All right? So that's those two parts of the name. Let's figure out the rest. Okay, well, what do you see at the end of this name? All. All right, what do you think the all signifies? The alcohol. All right, and now in this particular case, let's see where the number comes from. Which side did they start numbering from? The bottom row. So this would be number 1, 2, 3, 4, 5, 6. Because I didn't have a double or a triple bond, I had functional groups. I start numbering from the end closest to the functional groups. All right? Okay, so fabulous. Where was this alcohol functional group? On the 3rd carbon. So that's where you get the 3-hexanol from. All right, so in this case, we're going to do parent plus functional. And then number of functional. Isn't that kind of the pattern that we got here for this part of the name? What about this part of the name? Where's that coming from? Yeah, Lucas? There's rules for that, but you don't have to worry about it. But yeah, you would have to number both. This gets complicated, but yes, you'd have to number both. I don't want you to even worry about it because they're not going to ask it on the exam. And I don't want to confuse this any more than we have to. Okay? All right. So we named the parent, right, in this 3-hexanol. We named this functional group, but what do we still have left? We have that branch, right? Where is that branch? On the 3rd carbon, how many carbons does that branch have? 1. So this ends up being 3-methyl-3-hexanol. So that's where the name comes from. All right? So you name the branch plus then the number of the functional, the parent, then the actual prefix, the suffix for the functional group. All right, so let's try some of this. So 4-bromopentanoic acid. So let's start with the parent, the trunk. How many carbons in the trunk? 5. What kinds of bonds between those carbons? Single. So I'm going to do 1, 2, 3, 4, 5. All single bonds. All right. So we took care of the pent and the an. What about this oic acid? Actually, I should put an O in there in the prefixes. Oic acid. What's that the suffix for? A carboxyl. All right. So we got to put this. Does it matter if I put it on the 1st carbon or the last carbon? No, it just has to be on an end. It's got to be a terminal carbon. So we're going to do OOH. Because you're putting it on an end, you don't have to number it. Because whatever end you put it on, whether I put it here or there, I would then number that carbon, carbon number 1. There's only one position where it can be. You can't stick it in the middle of the chain. All right? And then now, what about this 4-bromo? Give me a second, Stephen. What is 4-bromo? On the 4th carbon, so if this is 1, 2, 3, 4, what do you think bromo means? I'm going to put a bromine. Okay? And so now you go back in and you fill in the rest of the slots, the rest of the bonds that the carbons need to have with hydrogens. All right? So then this carbon here would have 3 hydrogens. This carbon there would have another hydrogen. That carbon has 2. This carbon has 2. And we're done. Stephen, what's your question, hon? You could if you wanted to. I just got lazy. Here. Yes. So if you wanted to really be thorough in this picture, you'd have to put dots there, dots there, dots there. Okay? And that's what you would be expected to put on an FRQ on the College Board exam. But in all honesty, organic chemists don't even bother. They really don't bother. It gets to be cumbersome to put all those dots everywhere because that's not the important part of the structure anymore. Okay. All right. What about 4-heptanone? Heptanone. So what does this hept tell you? 7 carbons. 1, 2, 3, 4, 5, 6, 7. An means what? Single bonds. One means it's a ketone, right? That's what this table up here tells me. If it ends in "one," it's a ketone. What does a ketone look like? Doubly bonded oxygen somewhere in the middle of that chain. And the name tells me exactly which carbon to put it on, right? The 4th one. Okay, well, which one's the 4th one? It doesn't matter in this case where I start numbering from. It's going to be that guy right there. All right? And so now I go back and I fill in the rest of the carbons, give them their 4 bonds by putting in hydrogens everywhere else. Looks like that. Pretty symmetrical, huh? So in terms of polarity, what would you anticipate? Pretty nonpolar. You had a question, right, about methanone versus methanoic acid? How about this guy here? I had people tell me that things with a COOH on one end was symmetric. Is that symmetric? No. It would be symmetric if you had another one of these on the other side, but you don't. Okay? All right. Let's take a look at the next guy. What's the longest chain of carbons there? 4. What's the prefix for 4? Bute. Butene. All right, and then we have to name the functional group, right? What's the functional group here? Is it this piece right here? That's an aldehyde. Perfect. Just like formaldehyde, right? Formaldehyde has that kind of a structure on the end. Now, what's the suffix for that? Butanal. Do we have to list the number where that goes? No. Why not? Because the butanal is always going to be on the first carbon. Same as the carboxylic acid. It's always on the first carbon. All right, fabulous. So what do we have left to name? Yeah, because the aldehyde or the carboxylic acid has to go on a terminal carbon. And if you do that, when you go to number the parent chain, you would still number that carbon number 1. Does that make sense? So if I had drawn it on the other side, then that would have been carbon number 1. For these ones, you start numbering from the functional group. Right? So 1, 2, 3, 4. So then this would be... No, hang on. No, I'm wrong. You always start numbering from the bond. 1, 2. Yeah, we're not changing the rules on us. Start numbering from the bond, right? So this would be what? One butanol. Okay, let's take a look at the next one. Well, hang on, that's not right. That's not right. Hang on. Let me read the rules. Take note of the position of the functional group. You give the position of the functional group before you give the position of a multiple bond. See, this is where it gets heavy. Yeah, I agree with you. I would number them from the functional group. Yeah, 1, 2, 3, 4. So this would be 3 butanol. Because you pick the smaller of the 2 carbons that it's attached to. It's 3. Right? So if we start numbering from the functional group, right, this would be carbon number 1, number 2, number 3, number 4. It's after number 3. So 3 butanol is what I would call it.
So what is that?
Where the double bond is. You don't have to tell the position of the aldehyde. You know it's got to be on number 1, so you give the position of the double bond.
So that prefix number either tells you where the bond is,
yeah,
or where
functional
comes off,
yeah,
or where.
Yes, it can.
If it's natural.
Yes. Okay. All right. Let's take a look at the next one. See, this one's ugly, huh? All right. So let's go ahead and figure out what the longest chain of carbons is for this. It could be 1, 2, 3, 4, 5, or it could be 1, 2, 3, 4, 5, 6. I like 6 better, right? So I'm going to call this my parent branch. What functional group do you see on this? It's right here. It's a carboxyl. All right, and what kinds of bonds do you see within that trunk? Single. So the latter part of the name is going to be hexanoic acid. I know, man, he's like on fire today. Proud of you, Allegra.
So why did you decide to go to the right instead of the left? Because if you count laterally, you have to branch to 6 carbons.
No, you don't. It's 1, 2, 3, 4, 5 carbons. You have to start on the carboxyl group. All right, so then this would be 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5, 6. You always go with the longest chain to be your parent. All right, so we already took care of this and the functional group. You don't have to put the number for the functional group because you don't have a choice with carboxylic acids. They go on one terminus or the other, and in either case you call that carbon number 1. So this would be 1, 2, 3, right? We don't have to keep numbering. But you see that you have one branch coming off where? Off the second carbon, right? And it's a 1 carbon branch, so that's a methyl group, right? And then you've got a 2 carbon branch coming off the third carbon. So this is 2 methyl, and then what do you call this? This would be 3 ethyl. All right? And so when you place the names of these branches here, you do it alphabetically, right? So what would come first, eth or meth? So this is 3 ethyl. We've got to put dashes everywhere. 2 methyl. You go alpha. When you're doing branches, you go alphabetically. 3 ethyl, 2 methyl hexanoic acid. You see how hairy this gets? And I'm only teaching you this in like 40 minutes. Imagine taking an entire month of this in college. The rules get extensive. Okay? All right, last one. Listen, don't fear. You're not going to have things this nasty on the AP exam. Just chill. Okay? All right, look at this next one. What's the longest chain of carbons? Is it 1, 2, 3, 4? No. So I'm going to start here on the functional group. So 1, 2, 3, 4, 5. Okay, so my parent is going to be penta, and they're singly bonded, right? So pentan, where's the functional group? Is it right there? What kind of a functional group is that? It's an aldehyde, so this is pentan al. Al. Okay. Be careful how you pronounce that, because the way you said it, Lucas, it sounded like that was an O.
That was Anna.
That was Anna? She threw her voice in such a deep way? Pentanol. Pentanal. Okay. All right. Do I have to number where the aldehyde is? No. All right, so now let's take a look at the branches. So we have a branch here. We're going to start numbering this number 1. So we have a branch at number 2, and we have a branch at number 3. The branch at number 2 has how many carbons in it? 1. So this is going to be 2-methyl. That's what that little group is called. And what about, I'm sorry, don't we have another methyl on 3? So this is 3-methyl. Should we call it 2-methyl, 3-methyl, or could we condense that name? It's 2, 3, dimethyl pentanal. Yeah, and so rather than calling it 2-methyl, 3-methyl and making the name too long, you say 2,3-dimethyl. It helps you abbreviate a little bit. Okay? All right. So numerical order. Numerical order.